Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. We're going to today continue talking about quadratic functions and equations, but we're going to now step it up another level. As of right now, all of you should feel very comfortable and confident in A, graphing a quadratic function. You find the axis of symmetries, negative b over 2a, that equals x. That's the x value of the vertex. The vertex is you plug that negative b over 2a, that x value into the function, you find the y value. You find and graph the y-intercept, which is 0, c, the y value on the y-axis when x is 0. And then you use a test point if needed, if the vertex and the y-intercept are the same. Or if it's factorable, you factor the function, you find your zeros, you plot those as well. And then you graph, and you're done. All right? That's all nice and good. But what happens when you cannot factor? The first tool that we're going to use is called completing the square. There are several ways to solve a quadratic equation or function, such as y equals ax squared plus bx plus c, or f of x equals ax squared plus bx plus c. Remember that y and f of x are the same thing. We can solve this by using a square root method, by completing the square, by using a quadratic formula, by factoring, or by graphing. We got these two down. That's it. We know how to factor and we know how to graph. Today I'm going to teach you how to use the square root method and how to complete the square. All right? So let's get to the first one, the square root method. In order to solve quadratic functions or equations using the square root method, the function must be in the following form, guys. Y equals ax squared plus b. Notice that there is no bx value. B is 0 here. When the function is in the above form, simply set y equal to 0 and solve for x. Your solutions are the x-intercepts. They're also called the real zeros, or they're also called the roots of the function. So this method that I'm about to teach you guys only works when it's in this format. Only, and only when it's in that format. Y equals ax squared plus c. There is no x value by itself with a power of 1. There's only an x squared value, maybe a number in front of the x squared, a coefficient, and then there's going to be a constant. When it's in that form, and that form alone, we're going to use the square root method. For example, I got y equals x squared minus 64. First thing I'm going to do here is realize, hey, wait a second, cool. I don't have an x value. So I can go ahead and solve by the square root method. First thing I'm going to do is I'm going to set y equal to 0. Now, some of you may say, Morrow, that's factorable. We can solve this by factoring. Yes, in this particular case you can because it's a difference of squares. But let's just put that aside for a second. Let me just show you how the square root method works. I want to solve for x, so I got to get this x squared alone, so I'm going to go ahead and add 64 to both sides. So x squared equals 64. Now, the skill that I'm about to reintroduce to you guys has been taught to you several times before. Let's see if you guys remember, because I believe in you. What cancels out a power of 2, boys? Square root. I'm very proud of you, gentlemen. So what happens is, you're going to go ahead and square root both sides of the equation to cancel out that power of 2. So I'm going to square root both sides. Now, x will equal, this is the part that messes a lot of people up. Thank you, my man. Say it out loud. Very good. It's a plus or minus 8. Very good, son. Very proud of you, my man. Good job. A lot of people forget that. Why is it a plus or minus? Well, because 8 times 8 is 64, but so is negative 8 times negative 8. So those are my solutions. Now, you know that sometimes this could be good or bad, but you know that I like to repeat a lot of things to make sure you understand. So I'm going to be a little bit redundant right now. But I want to make sure that you walk away knowing this, guys. This is really important. What does this x equals plus or minus crap mean? Well, think about it, guys. Let me show you how to sketch a graph really quickly, because it's pretty cool. This is not an exact graph. This is what's called a sketch, just so you can understand what's going on. First of all, the a is the coefficient of x squared. Is it positive or negative? So is the graph going to be pointing upwards or downwards? Upwards. That's half the battle right there. Okay. What's the y-intercept here? Negative 64, right? So you're going to have a y-intercept over here of negative 64. There is no b value, right? So the axis of symmetry is x equals 0. So it's going to be right here. So that means my vertex and my y-intercept are the same in this particular case, right? But what are my solutions? Here's where the negative 8 and the positive 8 come into play, and fwagada. That's my graph. That's what that x equals plus or minus 8 gives you. It renders you the solution, the x-intercepts, the zeros, the roots. Thank you. Does that make sense, guys? You do not have to graph this. You're done when you say x equals plus or minus 8. But darn it, I want to do a good job. I want you to walk away here going, oh, okay, yeah, that's what the x-intercept means. This is the point on the x-axis that the parabola hits. Okay? So, let's go to number 2. I'm going to set that y equal to 0, and that equals 3x squared minus 27. I'm going to add 27 to both sides. 27 equals 3x squared. I'm going to divide by 3 to both sides. 9 equals x squared. I'm going to square root both sides. X equals plus or minus 3. And again, hopefully you understand that that means that this particular quadratic function is going through the x values of 3 and negative 3. Those are the solutions. Does that make sense? Thank you, my brothers. Okay. Now, let's get a little bit, not complicated, but yeah, a little bit more complicated. I got x minus 2 in parentheses squared equals 25. Uh-oh. What do I do here? Yes, sir, my brother. Thank you. This is even easier, actually. You square root both sides right from the beginning. Square rooting both sides cancels out that power of 2, my brothers. So I've got x minus 2 equals plus or minus 5. So I got to solve for x, so I'm going to add 2. This is where some people get messed up. So this means x equals plus or minus 5 plus 2. So it's positive 5 plus 2, comma, and negative 5 plus 2. So my x will equal 7 and negative 3. Does that make sense, guys, what I did there? Because that plus or minus really tends to mess people up sometimes. People either forget that it's 2 values or they just forget the negative value. But you had there, when you cancel out the power of 2, you had x minus 2 equals plus or minus 2. Sometimes people see this a little bit differently, and this works for you. That's great. It will not. I will never do this because it wastes too much time. But if you, for whatever reason, can't understand that concept, do it like this. X minus 2 equals positive 5. X minus 2 equals negative 5. And then you can solve that way if you want as well. But if you understand the concept, I have this plus or minus 5, and I am adding this 2 to that. Well, I've got 5 plus 2, which is 7, and then I got negative 5 plus 2, which is negative 3. Does that make sense, my brothers? Okay. Next. Very good, son. I'm going to subtract 20 to both sides. And then I got y minus 5 squared equals negative 16. Very good, my brothers. So I've got y minus 5 equals plus or minus 4i. Very good. Now I add 5 to both sides. I cannot add whole numbers and imaginary numbers, so y will equal literally 5 plus or minus 4i. Does everyone see that? You need to be honest with me so I can help you. If you're honest with me, I can help you. If you don't talk to me, I cannot read your mind, unfortunately. Okay, then. Let's continue. Y equals x squared plus 81. I want to solve for x. So this is 0 equals x squared plus 81. Subtract 81 to both sides. I've got negative 81 equals x squared. Square root both sides. X equals plus or minus. Yep, I just messed up. Sorry. Plus or minus 9i is completely 100% accurate. Now remember what the I means when you have solutions. When I have a solution that includes an I, is that an x-intercept? No. It's a solution. Heck yeah. It's an imaginary or complex solution. But it is not an x-intercept. It's a solution, but it's imaginary. So that means it's not a real solution. That means it never goes to the x-axis. So in these kinds of equations, these are the equations that are going to look like this. They never intersect the x-axis. Make sense? Yes, sir, my brother. Thank you. And then you're next, Papa. Yes, sir, my brother.
Kind of related to this. For like a real world situation, why does how does it not intersect with the x-axis affect something?
Okay. The question was, how can this be in a real life situation? How about floating a satellite floating in space? It's not going to hit the ground at all, right? You have an imaginary solution there. Right? Does that make sense, my brother? Go ahead, my man. No, please.
I was just saying, like, to see what axis is, like, it'll go around the world, like, yeah, it's imaginary line, right?
Correct. That's absolutely correct. Well done, my brother. Well, the axis around globes. Those are imaginary lines. They're not connecting to anything. Very well done, my brother. Sir.
How would you graph that? Or like put the points, the positive, negative, 9, 9?
Oh, okay. Remember, the question was, Mr. Morrow, how? That's a brilliant question. Very good question, guys. How do I plot these points? Remember, they're not points. They're not x-intercepts. So you're never going to be able to actually plot the value of plus or minus 9i, because I'm not being sarcastic. It's imaginary. It doesn't exist, my brother. So Morrow, how the heck do you graph this? Well, the y-intercept, think about it. We would go back to old school days. Axis of symmetry. The axis of symmetry here, remember the axis is negative b over 2a. There is no b. So x equals 0. My vertex, when x is 0, y is 81, so my vertex is 0, 81. My y-intercept is 0, 81. Uh-oh. Uh-oh. I have the vertex and the y-intercept at the same value. No big deal, Morrow. You already taught us that. You choose an extra point. So let's choose an extra point. Let's say when x is, I don't know, 1. There you go. When it's 1, y is 82. Okay? So now I'm going to go ahead and graph this bad boy. So my y-intercept is 81, and that is also my vertex. All right? And then in this particular case, 82 is over here. So I got 1. That's 1 to the right of the axis of symmetry, 1 to the left of the axis of symmetry, and I go up like that. Did it ever touch the x-axis? Why did it not touch the x-axis? Because it's an imaginary solution. Does that help you, sir?
Thank you.
No, thank you for the courage of asking. John, sir, does that help you? And my other brother?
Yeah.
Thank you, my man. No, thank you, guys. Okay. May I erase that part, the graphing part? Thank you. they don't want to do that, whatever. Okay. Last but not least, subtract 14 to both sides. X squared equals negative 12. Square root it. X equals plus or minus 2 square root of 3. Nah. 2i square root of 3. Come on, Moro. Come on, Moro. Come on, Moro. Plus or minus 2i square root of 3. If you don't know how we did that, think about it. 4 times 3 is 12. All right. So the square root of 4 is 2. Pulled out that 2i. Does that make sense? Good. If you know this, it's going to make the next step a little bit easier. Okay? So you ready?
Yes.
All right. Many teachers, by the way, and I'll be proud to put this on my recording. Many teachers will say, oh, no, let's not teach it. It's too complicated for the kids. I believe in you, and I know you can do this. All right? So let's be positive, and let's knock this out. Completing the square. Completing the square is a whole different ball of wax, guys. Completing the square allows you to transform unfactorable trinomials into factorable perfect square trinomials. How does it work? You can make a perfect square trinomial, okay, from x squared plus bx by simply adding b over 2 squared. That's how you complete a square. So what does that mean? Therefore, if I have x squared plus bx, if I add b over 2 squared, I'm going to have a perfect square binomial. I'm going to show you how and why this happens. But this is what's going to happen. This is what we're doing. We're going to create a perfect square trinomial. Now, before we learn how to solve quadratic equation by completing the square, let's just practice the simple act of completing a square. Let's first do that. And then I'll show you how to solve using this skill. Number 1. So complete the square for the given binomial. Okay, I have x squared minus 10x. I know that in order to complete the square, I have to add b over 2 squared. So the first thing I'm going to do is identify the b. So what's the b here, guys? B equals negative 10, not x. This is x squared minus bx. B is b, x is x. They're not the same, my brothers. Step 2, find b over 2 squared. Okay, well, b over 2 squared, this is going to equal negative 10 over 2 squared, which equals negative 5 squared. Bless you. Number 3, add the value of b over 2 squared to complete the square. So I have x squared minus 10x plus negative 5 squared. Step 4, rewrite as a perfect square binomial. Okay, now this is where the book and I and many teachers and I disagree. Okay, there's 2 trains of thought here. The way the book's going to teach you, the way most teachers are going to teach you, they're going to tell you the following. Calculate this value of b over 2 squared. So they're going to tell you go x squared minus 10x plus 25. And they want you to factor this. This is a perfect square binomial that we created. Every time we do this, we create a perfect square. So what times what is 25 when added together is negative 10. So this is x minus 5 squared. And that's it. I completed the square. So go ahead and write that down, please. And then I'm going to show you my way, which I think is infinitely easier, more understandable, and just all around better. While you're writing, I'll just repeat what we did. We identified the b, which was negative 10. Then we find b over 2 squared, which is negative 10 over 2 squared. Negative 10 over 2 is negative 5 squared. The way the book and most teachers will teach you, they'll tell you to calculate that value of b over 2 squared, which is 25. Then they want you to factor as a perfect square binomial. That's all fine and dandy, and that's all good and sweet. However, I like my method better. My method skips a step. Bless you. In my method, this is what I do. I know that I did the math here correctly, okay? This math is correct. Now I got to create a perfect square binomial. So check it out, guys. Take the first term, and what's the square root of x squared? Bam. Now, this second term, just take the inside part of it with the sign and everything. Minus 5, and you square it. Did I get the same answer? Why do I like this better? Because you don't have to go forward to go backwards. What do you mean, what did I do? I just took the inside part of this negative 5, and I put it right there. Yes, that's it. If you want to go ahead and square it and then factor it, do it. God bless you. But I suggest strongly to just realize that this is a much quicker and easier trick. Yes, sir, my brother.
Why do the book and other teachers do that?
Okay, the book and the other teachers that do it the first method are doing nothing wrong. The question is more, Mr. Morrow, why are you doing it your way? Let me explain. What if we get to a situation like this, guys? What if I have x squared plus 3x, okay? I'm going to have to add now my b over 2 squared. b over 2, this is 3/2 squared. My method. First term, square root of that, that's x. Plus. Oh, actually, not plus. It depends. Now I take the inside part of the b over 2 squared, basically the b over 2, and I plug it in right here, plus 3 over 2. And I square it. The book and other teachers will tell you, no, go x squared plus 3x plus 9/4. Be honest, guys. Are you going to really be able to ask yourself what times what is 9/4, but when added together is 3? Be honest. No. So that's why I did it. It's not because you can't, it's just because it's not as common. And this is going to lead people to make mistakes. I'm here to make sure you don't make mistakes. I'm trying to make your life easier. So that's why I did it that way, my brothers. Do you see how much easier my way is? Especially when you're putting fractions into the game. All right? Let's practice it a little bit more, my brothers. Let's just complete the square. Sir. No, we're just completing the square. We have not solved anything yet, please. We're just learning the skill of completing the square. So I got x squared plus 6x plus b over 2 squared. So I take the first term, x, and then I take the inside term, which is plus 3 squared. Bless you. Done. This is x squared plus 8x plus b over 2 squared. So 4 squared. So this is x plus 4 squared. This is x squared minus 32x plus b, which is negative 32 over 2 squared, is negative 16 squared. So this is going to be x, take the inside, negative 16 squared. Are you starting to see this yet already, guys? Yes, sir, my brother. Exactly. You're basically putting in this guy right here, b over 2. Whatever the b over 2 was, it's right in here. So you can model it like this, x plus b over 2 squared. Yes, that's exactly what we're doing. Well done. Yes, it is easy, my brother. And that's why I like to teach it that way. Thank you. Good job, my man. Now, again, here's a little bit of an uglier one, but I want this on purpose. Because I want to show you, it's not that I'm crazy, it's that I'm trying to make it easier for you. This is x squared minus 5x plus b over 2 squared. So, using the easy trick, it's the x, and in this case, I have b over 2, which is negative 5 over 2, and then I square it. I take the inside value, which is the b over 2, and I put it right there. Does that make sense, guys? Remember, if you did it the long way, this would have been x squared minus 5x plus 25/4. Please, no sarcasm at all coming from this body right now. But would you be able to answer that quickly? What times what is 25/4, but when added together is negative 5? No, you wouldn't. And it's okay. That's okay, guys. I've been doing this a long time and I can see it, but ooh, whoop-de-doo for me. I need to make sure that you guys can handle this. So that makes sense, brothers? All right. Now, now, now let's do it all the way. How to solve a quadratic function by completing the square. We know how to complete the square. Let's see how we can use that skill to solve an equation. All right. So step one. See if you guys remember. Do you see something common to all of these guys? Yeah. Okay. So first of all, I'm going to isolate ax plus bx and divide a to both sides unless a is 1. Then I don't have to divide anything. So when I do that, I'm going to be left with x squared minus 4x plus 2 equals 0. Okay. Now I want to isolate the x squared and bx. So I really have x squared minus 4x equals negative 2. I'm going to chill right there for a second. I want to make sure everyone sees what I did. If there's a GCF, factor it out, dog. Divide it out, rather. Not factor, divide it out. Okay? Step 2. Complete the square by adding b over 2 squared to both sides of the equation. When I complete the square, I add b over 2 to my original function. But if I do something to one side of the equation, I must do it to the other side of the equation, guys. Okay? I must. So, I have here x squared, very good, minus 4x plus negative b over 2 squared equals negative 2 plus negative b over 2 squared. I added the b over 2 squared to both sides. Does everyone see that, my brothers? Okay. All right, so I added that b over 2 squared to both sides. Now let's factor the trinomial. Okay, we already learned how to do this. Take my first x squared, and it's x. And now I add the b over 2. Not the b over 2 squared, because that would be 4. But just the inside part, just the b over 2. So that would be minus 2 squared equals negative 2 plus 4 is 2. Now, thank you, my brother. Darn it, that made me happy. Now we, whoa. Okay. Now we square root both sides. So x minus 2 equals plus or minus square root of 2. Now I add 2 to both sides. And x equals 2 plus or minus square root of 2. And my brothers, that is my solution. Now, some of you may say, okay, not bad, Moro. How do I plot those points there, though, dude? What the heck do I do? Well, think about it. X here equals 2 plus square root of 2, and it also equals 2 minus square root of 2. That's where a calculator comes in handy. 2 plus square root of 2 equals 3.41. So that's one of my x-intercepts. And then I got 2 minus the square root of 2, which equals 0.59. And that's my other solution. So they're not pretty, but they're totally calculable. Does that make sense, guys? We're going to do a lot of practice now. Sure, my brother. Thank you.
So after you find when you put the b over 2,
When you put the b over 2 squared to both sides, yeah.
you never combine them?
What do you mean combine them?
Because like on I said you have -2 plus -2 squared, like it wouldn't be.
Oh no, you have to add this side, Papo. You got to add that side. That's how I got. Um, that's how I got that 2 to begin with,
Oh yeah.
right? Because I went -2 plus -2 squared. So -2 plus 4 would have been 2. Okay. Let's give another example out. So another example out. So now we're just going to solve each equation. All right. Let's see what we got. First of all, I'm going to subtract the 3 here to both sides. And I'm going to subtract an x to both sides. Giving me 2x squared minus 2x equals 6. I have a 2 here in front of the x squared, so I'm going to divide 2 to both sides because I want to get the x squared alone, my brothers. Now, I'm going to complete the square. So I've got x squared minus x plus b over 2, which is -1/2, squared equals 3, top plus -1/2 squared. Why? Because I added my b over 2 squared to both sides. Now I factor this perfect square binomial. That's going to become x, and then the inside part minus 1/2. Remember, the inside part is simply the b over 2. Then that's going to equal 3. Come again? It's squared, thank you. That's going to equal 3 plus 1/4. Are you with me so far? Are you sure you want me to chill for a second? Because we're going to have to do some more math. Okay, I'll chill for a second. Thank you, my brothers. Okay, you ready? Okay, so this goes to 4. Bless you. This goes to 12. So I've got x minus 1/2 squared equals 13/4. Square root both sides. X minus 1/2 equals plus or minus square root of 13 over 2. Add the 1/2 to both sides. X equals 1/2 plus or minus square root of 13, all of it over 2. A lot of math, sir.
Would you get 2?
Thank you, my brother. Square root of 13/4. How do I get this 2? Square root of 4 equals 2. No, thank you. Thank you. Thank you, thank you, thank you.
So the 2 is not affected by the square root.
I'm sorry, my brother?
2 is not affected by the square root anymore.
No, because the square root of 4 is 2. That's it. It's out of the square root.
Okay.
Thank you, my brother. Okay, let's try this bad boy. First thing I got to do is set that to 0 and add 6 to both sides. That gives me 6 equals x squared plus 3x plus b over 2 squared, which is 3 over 2 squared. And I add that to both sides. So now I have 9/4 plus 6 equals x plus 3/2 squared. I went ahead and created my perfect square binomial. This goes to 4, that goes to 24. That's 33/4 equals x plus 3/2 squared. Square root both sides. Plus or minus square root of 33 over 2 equals x plus 3/2. Subtract 3/2 to both sides. And you get x equals -3/2 plus or minus square root of 33 over 2. Okay, why? Why? Where did I lose most of the classes? No problem. But with all due respect, I would rather you guys help me and say, sir, please, could you explain what you did? Sir, could you stop for a second, please? I don't think it's very fair for me to do the whole problem thinking that you guys are with me and then you tell me that you're lost. So where is it that you got lost so I can help you get found? Please and thank you. Okay, well, if you don't know the steps, I cannot help you. That's not me getting lost. That's you getting lost. Yes, sir.
Plus or minus.
That's not my fault, though. That's not my fault. Yes, sir.
The final answer is plus or minus. Is that the entire fraction, or is it minus the product of it?
Yes, x equals negative 3 halves plus or minus the square root of 33 over 2. Yes, sir.
When you get the final like that,
Yes, sir, my brother.
what you're done. Or
You're done. If I wanted the actual values for that, you could plug that into a calculator. But 9 out of 10 times, they're going to display the answers in radical form anyways. Sir. Okay? Let's do another one. Subtract 4 to both sides. So please pay attention so you don't get lost. Please. This equals 96. I'm going to add b over 2 squared to both sides. I'm going to now create my perfect square binomial, which is x, and then the inside part, the b minus 2, the b over 2 rather, squared equals, that's 96 plus 4 is 100, square root both sides, x minus 2 equals plus or minus 10, add 2 to both sides, x equals 10 plus 2 is 12, and negative 10 plus 2 is negative 8. Sir, did you follow me on that one? Sir, so I can help you, my brother. Yes, sir.
so all of them aren't going to be though like the answers aren't going to be.
No, that's why I did different ones. They're not always going to be with fractions. They're not always going to be with square root. Sometimes they'll be whole numbers, my brother. Yes, sir.
Sir, the
Thank
one
you.
we did before,
Yes, sir.
does the plus or minus
For this one?
only affect the radical?
No, the plus or minus is affecting this whole entire fraction right here. Yes, sir. No, thank you, my brother. Does that make sense, guys?
Yeah, I got this one. This one, like, I got that one. I start last one.
Okay? All right, I think I can squeeze in the last one right quick. If the bell rings, you are dismissed, but just please don't be too loud because I'm going to continue with this one. Please. So let's go. We've got 9x squared minus 12x equals 2. I'm going to divide a 9 to everything. So I got x squared minus 12 over 9x equals 2 ninths. You are dismissed. If you want to stay for this one, God bless you. If not, please watch the video. I can reduce this 12 ninths. I want to work with easier numbers. So I'm going to go x squared minus 4 thirds x. That equals 2 ninths. Now, I've got to add b over 2 squared. Pay attention to this. My b in this case is negative 4 thirds. So b over 2, state change flip, you're really multiplying by 1/2. So this gives you negative 2 thirds squared to both sides. So plus negative 2 thirds squared to both sides. This creates a perfect square binomial of x minus 2 thirds squared. And that's going to equal 2 ninths plus 4 ninths, which is 6 ninths, square root both sides, x minus 2 thirds equals plus or minus square root of 6 over 3. Add the 2 thirds to both sides, and x equals 2 thirds plus or minus square root of 6 over 3. The majority of you are here, so do you see that? Are there any questions on that? Thank you so very much, my brothers. God bless you all, and have a wonderful day. Hope you learned a lot. Thank you.
That is, you know,